Okay, let's unpack this. Toner refills.
Ah, yes.
That moment you think you're being smart, saving some cash,
Wow.
only to end up, looking like you wrestled a chimney sweep, black dust everywhere.
It's a classic problem, isn't it? That
Yeah,
fine powder just gets airborne so easily.
totally. So today, we're taking a deep dive into a piece of technology that, well, aims to banish that exact frustration. It's called the Minus Ultimate Vacuum Filler.
And what's great is we've got a fair bit to go on catalog info, a user guide, website content, even a YouTube demo.
Yeah, good mix.
And they all point towards, actually, a pretty clever way to tackle this notoriously messy job.
Exactly. And for you listening, our mission today is really to get under the hood of this machine. We want to understand how it works, what the benefits are, and, ultimately whether this whole vacuum-based approach could finally mean cleaner, more efficient, maybe more precise toner refills for good.
Sounds like a plan. Where should we start? The core tech.
Let's do it. Let's dive in. So this vacuum filling technology.
Right. It's quite a direct name because it really does just use the power of a vacuum.
Okay.
So the process, basically, you start by placing your toner cartridge, or maybe a bottle, inside this specially sealed chamber.
Right, like an airlock or something.
Kind of, yeah. Then the machine draws the air out,
Yeah.
and that creates quite a significant pressure drop inside that chamber.
Okay, so you're creating a low pressure zone.
Exactly. Think about, like, when you seal up a food container, sometimes the lid dips in a
Yeah.
bit. It's that idea, but much stronger. And here's the really neat part. Because of that big pressure difference between the inside of the chamber and the outside, the toner powder is literally pulled or drawn from a separate portable container directly into your cartridge or bottle.
Wow. So it's not being pushed or pumped, it's being sucked in by the vacuum.
That's it. Like the machine is gently inhaling the toner. And it's smart enough to know exactly when to stop.
Okay, how does it do that?
Well, the system's engineered to automatically halt the toner transfer once the precise amount the way you set beforehand has been dispensed.
Ah, so there's a scale involved.
Definitely. And what's really key, I think, is this idea of an isolated environment.
Right, because it's all happening inside that sealed chamber.
Exactly. So those incredibly fine, floaty toner particles, they just have nowhere to go. They can't escape into your workspace.
Which is frankly a massive relief for anyone who's ever had a toner mishap.
Oh, absolutely. Black powder is not fun to clean up.
And it's not just about keeping things tidy, is it? You mentioned it uses vacuum power, not motors or pumps like some other systems might. That seems important.
It really is. By harnessing physics, that pressure differential to move the toner, they've bypassed a really common problem in powder handling stuff.
Which is?
Clogging. The dreaded clogging of the filling line.
Oh, yeah. Toner's so fine, I can see how it would block things up.
It easily clumps up, blocks mechanical pumps, tubes, you name it. This vacuum method pretty much eliminates that risk.
Okay, so cleaner process, less chance of frustrating clogs. Those are pretty compelling advantages right off the bat.
For sure.
But the benefits of this vacuum filling thing, they seem to go even further, especially when it comes to like actually using all the toner you paid for.
Yeah, that's another insightful bit. The vacuum doesn't just move the toner, it also kind of conditions it inside that portable bin.
What do you mean, conditions?
Well, the documentation mentions that the vacuum action itself sort of mimics shaking a toner bottle. You know how you shake it to loosen the powder so it flows well?
Right, yeah.
The vacuum does something similar inside the bin. It helps loosen it all up. And that means you're likely to use a much higher percentage of the toner in there. Less waste compared to systems just relying on gravity.
That makes perfect sense. It's like the machine is helping you get every last useful speck.
Pretty much.
Okay, and then there's the precision. We know it stops automatically at the set amount, but like, how accurate is it? And what else helps get a really good fill?
Well, stopping at the right weight is obviously crucial. But the machine also uses the release of the vacuum quite cleverly.
How so?
Once the target amount is in the cartridge, the system lets air back into the chamber. But it's a controlled release.
Okay.
And this gentle return of air helps the fine toner particles settle down more uniformly. It kind of compacts them slightly, naturally.
Ah, so you get a denser, more consistent fill.
That's the idea, which could potentially mean better print quality down the line from that cartridge.
Interesting. And what about colors? Because, it's not all just black toner out there. We've got cyan, magenta, yellow.
Good point. And yes, the machine accounts for that. The Mez Ultimate is equipped with these independently adjustable valves on each filling line.
Valves. Okay, so you can control the flow.
Exactly. It gives you really useful control over the speed at which the toner is transferred. And the doc specifically mentioned that color toners, cyan, magenta, yellow, often have finer particles than black toner.
Right, they can be almost like dust.
They can. So these adjustable valves let you slow down the flow for those finer powders.
Why would you want to slow it down?
It helps prevent them from becoming too dispersed, like too airborne even inside the system, or creating unwanted clouds of color powder when it fills. Better control.
Gotcha. So it's a system that's really trying to adapt to the different properties of the actual toners. Smart.
It seems that way.
Okay, let's walk through the actual filling process then. Automatic sounds great, but what exactly happens step by step when you use this thing?
It seems quite logical, actually. First, like we said, the machine pulls a vacuum in the chamber. And for safety, the door automatically locks.
Okay, safety first? Good.
Then you select which filling line you need, say, if you've got black, cyan, etc., hooked up.
Makes sense.
The next key step is using the control panel. It's got that built-in digital scale we mentioned, and that's where you set the exact amount of toner, usually in grams, that you want to dispense.
Right. And that YouTube demo mentioned aiming for a specific vacuum level, something like 200 torr?
Yeah, they did, 200 torr.
For someone who isn't, a vacuum scientist, how strong is that? Is it like a household vacuum cleaner? Or more?
It's quite a bit stronger than your typical household vacuum. 200 torr means you've removed about 3/4 of the normal air pressure inside that chamber.
Okay, so pretty significant.
Definitely. It's strong enough to draw the toner effectively, but not so extreme it causes other problems. And once the machine reaches that optimal vacuum level,
It just starts filling.
it automatically starts the toner transfer from the portable bin into the cartridge or bottle.
Yeah. And it just keeps going until it hits the weight you programmed in.
Exactly right. The digital scale is constantly monitoring the weight. As soon as it registers that the target amount is reached, bang, the machine automatically stops the toner flow.
And then,
It releases the vacuum, lets the air back in gently,
right, to settle the toner.
and just as automatically, the chamber door unlocks. You can then safely take out your refilled cartridge.
Wow, that sounds genuinely easy. Almost set it and forget it for each fill.
Pretty close, yeah.
Yeah. And the documents mentioned a memory function. That sounds like a real time saver if you're doing batches.
Oh, absolutely. Very practical. If you're refilling, say, 10 identical cartridges, the machine remembers the last fill amount you set.
So you don't have to type it in every single time.
Nope. Just load the next cartridge, hit go, and it uses the same stored weight. Big efficiency booster for repetitive tasks.
Okay, I'm starting to get a clear picture of the process. Now let's dig into the actual physical parts, the components that make it all happen. We've mentioned the chamber, the control panel. What else is key?
Well, the portable toner bins are really central to the whole design philosophy, I think.
The ones the toner gets pulled from.
Yeah. Each filling line has its own dedicated bin, and they hold quite a bit, up to 20 kilograms of powder.
That's a lot of toner.
It is. And their portability is a major plus. You can easily move them around, place them where it's convenient. No need for complicated overhead silos or anything.
Easier setup, I guess.
Much. And the user guide even gives little tips, like gently rocking the toner bag before you put it in the bin, and carefully cutting the bag inside the bin to minimize any dust escaping.
Practical advice. What if the toner gets a bit compacted in the bin over time? Does it still flow?
Good question. They suggest a simple technique. Just gently swing the portable bins side to side.
Like rocking them.
Yeah, that motion helps break up any clumps or agglomerated powder, making sure it flows smoothly when the vacuum kicks in.
Simple but effective. Okay, what else? The lines?
The filling lines themselves, yeah, you can configure the machine with 1, 2, 3, or 4 lines.
So you could potentially refill multiple colors at once or have different types ready to go.
Exactly. Gives you flexibility. And another little detail from that YouTube video, they showed these tiny plugs
Plugs? For what?
to seal off the ends of any filling lines you're not currently using. Just keeps everything neat, prevents any stray powder from dribbling out.
Smart. Attention to detail.
Okay,
The control panel and scale, obviously vital. How do you actually, punch in the numbers?
the interface looks pretty straightforward in the materials. You've got dedicated buttons, usually labeled things like menu, select, then incrementer buttons, maybe a digit chooser to set the weight precisely.
And it measures in grams, you said.
Yep, gram level precision. And it even has a tear warning.
Tear, like on a kitchen scale.
Exactly. Reminds you to zero out the scale with the empty cartridge or bottle placed inside before you start the fill, so you're only measuring the toner added.
Crucial for accuracy.
Absolutely. And interestingly, that YouTube video pointed out that the load cell, the actual sensor that does the weighing,
Yeah.
It's located inside the vacuum chamber itself, but it's designed to be easily removed.
Why remove it?
For cleaning. If any toner does spill inside, you can take the sensitive part out easily to clean it properly. Makes maintenance simpler.
That is well thought out. Easy cleaning is always a plus. Now, the vacuum itself, it doesn't generate its own vacuum, right? It needs help.
That's correct. The Minimise Ultimate Vacuum Filler requires an external air compressor. That's what actually generates the vacuum power.
Any specific requirements for the compressor?
They recommend one with a tank capacity of at least 100 liters. That ensures you have a consistent supply of compressed air to run the vacuum system effectively without the compressor constantly cycling on and off.
Okay, so that's an extra piece of equipment to factor in.
It is. And the user guide also notes that the vacuum compressor part within the MIS machine uses oil. So there's an initial fill needed when you set it up, and you need to check the oil levels periodically. Standard maintenance, really.
Got it. And we already talked about those adjustable valves for controlling the flow.
Right. Key for handling different toner types.
So when you put all these pieces together, the bins, the lines, the scale, the vacuum system, the controls, it really does paint a picture of a system designed for, well, both getting the job done efficiently and making it easier on the user.
I think that's a fair assessment. The memory function speeds things up. The portable bins cut out messy pouring.
Right, no pouring into big hoppers.
And the vacuum container itself just makes the whole process cleaner. We said it before, but it's almost like they've managed to make handling a tricky powder feel more like handling a liquid. Much more contained.
That's a good way to put it. Okay, let's shift gears slightly. What about the company behind this? MIS Computer. What's their story?
Well, according to the info we've got, they have a pretty solid history in this specific field. They actually started out as a toner refilling service back in 2000.
Oh, interesting. So they were doing the refilling themselves first.
Exactly.
Yeah.
Which presumably gave them firsthand experience with all the challenges and pain points. That experience then led them to start manufacturing their own refilling machines in 2005.
So they've been building these things for quite a while now.
Seems so. And they've apparently built up a significant global presence. The materials say their machines are used in over 100 countries.
Wow. Okay, so they're not a small operation. They've presumably learned a few things over the years about what makes a good refilling machine.
You assume so. Their stated philosophy seems to focus on ease of use, making maintenance straightforward, and building durable machines meant to last.
Things users would definitely care about.
Absolutely. They also make a point of saying they source components globally, which they claim helps ensure that replacement parts are readily available if needed.
Which means less potential downtime for a business relying on the machine, right?
That's the implication. Easier access to parts, maybe quicker repairs. It suggests they're thinking about the long-term usability.
Okay. Before we wrap this up, anything else important someone should keep in mind? Any warnings or key considerations from the user guide?
Yeah, the guide does cover the usual but important safety precautions. Things like taking the time to actually read the whole manual first.
Always good advice.
Keeping the machine away from really humid places or extreme temperatures. Making sure it's on a stable, level surface. You don't want it wobbling.
Makes sense with a scale inside.
Verifying the voltage, though. Thankfully, this one seems flexible, 100 to 240 volts. Being careful with the power cord, not damaging it.
Standard electrical safety.
Right. Also, don't use it during a lightning storm, and definitely unplug it before doing any cleaning or maintenance.
Okay. And the big one we already mentioned.
You absolutely need that external air compressor. You won't work without it.
Got it. Okay, so let's try and bring this all together for you, our listener. What are the main takeaways here about the Menace Ultimate Vacuum Filler?
I think the absolute core benefit is how it enables cleaner, more efficient, and more precise toner refilling. It all comes back to that clever vacuum filling technology.
Right, the physics doing the work.
Exactly. And then you add the automated operation, the smart design features like the adjustable valves, the convenient portable bins, that time-saving memory function.
And all adds up.
It really seems to streamline the whole process and directly tackles those common frustrations, the mess, the waste, the inconsistency that people often have with manual or simpler refilling methods.
That really is the aha moment, isn't it?
Yeah.
Seeing how this specific tech directly solves those pain points we mentioned right at the start.
Precisely. And it does make you wonder, doesn't it? How might a system like this impact not just toner refurbishment businesses, but maybe how we think about automation for other tricky specialized tasks?
Yeah, good point.
If you listening have found this interesting and want to dig deeper, the manufacturer's website is misscomputer.net. And they have a YouTube channel too, MissComputerNet, with videos showing the machine in action.
Worth checking out if this sounds like something relevant to you.
Definitely.
And maybe that leaves us with a final thought for you to ponder. If vacuum technology can be applied so effectively to something as specific as toner refilling, where else could it pop up? What other, maybe unexpected, messy, or inefficient tasks out there might be just waiting for a clever vacuum-powered solution?
It's an interesting question about innovation in niche areas.
Definitely something to think about. Thanks for taking this deep dive with us today.